Hey guys, welcome back. Today we are going to identify conic sections based on equations. We're also going to write standard equations of conic sections. Conic sections come from slicing a double cone. If I have no squared terms in my equation, that's a line. How is that a conic section? If I slice right along an edge, I'm just tracing an edge there, that is a line. One squared term is going to be a parabola. A parabola comes from slicing like this, where I'm going through a base, but not through the other cone. Two squared terms, same horizontal and vertical stretch. That is a circle. That comes from slicing parallel to a base. Two squared terms with different stretches, horizontal and vertical, with a plus, that is an ellipse. That comes from slicing not through a base, but also not parallel to a base. And different horizontal and vertical stretches, both terms squared, with a minus, that is a hyperbola. And that comes from slicing this way, where I catch both edges, or both bases. The general form of any conic section is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, and we are going to use that to identify what these equations would graph as. So this equation right here, 3x minus 12y plus 7, has no squared terms. That means a is 0, c is 0. There's no squared terms. That is going to be a line. (11x squared plus 5x minus 8y). There's only one squared term. Either the a is 0 or the c is 0. That is a parabola. (3x squared plus 3y squared plus 4y minus 7 equals 0. So this time both squared terms exist, and they both have the same coefficient. So a and c both exist. They're not 0, and they are the same as each other. That is a circle. Okay, they are both positive 3 in front of the squared terms. That makes a circle. Here both squared terms exist, but they're different, and they have the same sign. That makes an ellipse. Here both squared terms exist, so a and c both are not 0. They're not the same number, and they are different signs. That makes it a hyperbola. Okay, so identify the conic section, then rewrite it in standard form. So we have both terms, both squared terms here, but they have opposite signs. That makes it a hyperbola. So to write it in standard form, the first thing I want to do is move this 134 to the other side. So I've got 3x squared minus 2y squared plus 32y equals positive 134. Okay? Next, I'm going to arrange it so x's are near each other, y's are near each other, but that's actually already the case, so I don't have to move anything. I'm also going to see if I can factor anything out of y and y squared terms. The x squared, that's the only x term there is, so 3x squared is going to stay as it is. But out of these two terms, I'm going to factor out a negative 2. So when I factor a negative 2 out of here, I'm left with y squared, and 32 divided by negative 2 is negative 16, so negative 16y. And then I'm going to leave a blank, because I'm going to complete the square. That equals 134. And algebraically, if I'm going to leave a blank here, I've got to leave a matching blank on the other side of the equation. Okay, so in this section right here, we are going to complete the square. So to complete the square, I need half of b squared. Half of b is negative 8. Squared is positive 64. Okay, so I'm adding a positive 64 right here. But I don't want to put plus 64 here because really, I didn't just add positive 64. I added negative 2 times positive 64, which is negative 128. So I've got 3x squared minus 2 times, and I'm going to factor this. Completing the square helps me to factor this into a binomial times itself. Okay, what multiplies to 64 and adds to negative 16? Negative 8 and negative 8. So it's y minus 8 times y minus 8, or y minus 8 squared. And 134 minus 128 is 6. To get into standard form for a hyperbola, I have to have that right side equal to 1. So I need to divide both sides, every term, by 6. 3 over 6 is 1/2, so this is x squared over 2. Then I've got minus 2 over 6 is 1/3, y minus 8 squared over 3, and 6 over 6 is 1. Next, I have x squared and y squared. I've got things on both sides. I want to set this equal to 0 to see what it is, so I need to move this and this and this over to the other side. 5x squared minus x squared is 4x squared. 6x plus 2x is 8x. Then I've got a positive y squared minus 4y equals 0. Both squared terms exist. They have different signs. They have the same signs but different coefficients. That makes this an ellipse. A and C are different, but they have the same sign. It is an ellipse. Now we need to get that into standard form, which is going to look just like this hyperbola, except that's going to be a plus there. So I've got my x's and y's arranged, but I need to put a space to complete the square, and I can factor a 4 out of this. You have to have a lead coefficient of 1 to complete the square. 4 times x squared plus 2x. So I factored out my 4. Plus y squared minus 4y. And I didn't have any constants to move over to the right. So I've got 0 plus, and then I've got 2 blanks to match these 2 blanks. So half of b is 1, squared is 1. I really added 4 times 1, so plus 4. Half of this b is negative 2, squared is 4. I added, there's nothing out here to multiply by, so I added another 4. The factored form. And really, to make this easy, if I cut b in half, I get 1. It's x plus 1 squared. That's my factored form. Cut this b in half, and I get negative 2. Y minus 2 squared is the factored form. Equals 8. Now I need to divide every term by 8. 4 over 8 is 1/2. X plus 1 squared over 2. Plus There's nothing to simplify here. Y minus 2 squared over 8 equals 1.